So far, we have discussed the definition of work and have solved problems where we are asked to solve the amount of work done on an object. However, we have not dealt with situations where we need to know how fast the work was done. This brings us to today's topic about power. Whether we are talking about superheroes or weightlifting, we have all heard the word power. But what does that mean in the world of physics? Well, power is defined as a time rate at which work is done. Power is also a scalar quantity, which just means that power cannot be expressed with a negative value. The unit for power is watt. 1 watt is equivalent to 1 joule per second. When dealing with a constant work value, we will be dealing with the average power. And this is defined as the work done over a time interval divided by the duration of that time interval. In cases where we do not have a constant work value, we will be solving for the instantaneous power. As the name implies, this is the amount of power measured at a specific moment in time. The instantaneous power is defined as dW over dt. To make our power formula more useful, we can introduce the force and velocity into the equation. As we previously learned, work is equal to the dot product of the force and displacement, which is another way of saying that it is equal to the force times the displacement times the cosine of the angle between the force vector and the displacement vector. So suppose that the force and displacement vectors were parallel to each other. This will make the angle between the two vectors to be 0. So we would get that the work is equal to the force vector, which is parallel to the displacement vector, times the cosine of 0. And since we know that the cosine of 0 is just 1, we would get that the work is equal to the force times the displacement. Now we can substitute this into the average power formula, and we would get that the average power is equal to the force that is parallel to the displacement vector times the displacement, all divided by the time. And what we can see here is that we have displacement over time. And if you recall from Unit 1, this is our velocity formula. So we have the average power is equal to the force times the average velocity. With this formula, let's try to solve some problems. So problem 1 states that an airplane's jet engine has a thrust of 335,000 newtons, and we are asked, when the plane is flying at 220 meters per second, what is the amount of power exerted? So the problem gives us the force, which is equal to 335,000 newtons, and it also gives us the velocity, which is equal to 220 meters per second. So since we have the force and we have the velocity, we can use the power formula, the average power formula, which is equal to the force times the velocity. And all you have to do is plug in these two values into the formula. So we have 335,000 newtons times the velocity, which is 220 meters per second. And if you plug into your calculator, you will get 7.37 times 10 to the power 7 watts. Problem 2 states that weightlifter A lifts a 200 kilogram weight to a height of 2.0 meters above the ground in 0.75 seconds. Weightlifter B lifts a 150 kilogram weight to a height of 2.5 meters above ground in 0.75 seconds. And the question asks, which of the two weightlifters uses more power to lift the weights? Was it weightlifter A, weightlifter B? Did they both use the same amount of power, or is there not enough information? So we're going to solve this problem on the next slide. To save some time, I already wrote down our givens. So this is weightlifter A, and I'll denote weightlifter as WL, and this is weightlifter B. So what we've learned is that the average power is equal to the work divided by the time. And from this unit, we've learned that work is equal to the force times the displacement times the cosine of the angle between the force vector and the displacement vector. And this is all going to be divided by delta t. Since the weightlifters are lifting the weight above their head, they will be pushing against the force of gravity. So this force vector is going to equal the mass of the weight times the acceleration due to gravity, which we denoted in previous units as g. And this would be multiplied by the displacement times the cosine of 0, since the force vector and displacement vector are in the same direction. And all this will be divided by delta t. And we can simplify this expression to mg times displacement, all divided by delta t. Now let's solve for the power exerted by the weightlifters. And I'm going to use a different color for each weightlifter. So weightlifter A exerted an average power that is equal to 200 kilograms times the gravity, which is 9.8 meters per second squared, times the displacement, which was 2 meters, all divided by 0.75 seconds. And this equals 5,226.66 watts. Weightlifter B exerted an average power that is equal to 100 kilograms times gravity, which is 9.8 meters per second squared, times the displacement, which is 2.5 meters, all divided by 0.75 seconds. And this equals 4,900 watts. So we can see that weightlifter A exerted more power. So the answer to this problem will be answer choice A. Weightlifter A uses more power to lift the weights. Thank you for watching this video and hope to see you next time.